Good morning, students. Today we are looking at a special type of diode called Zener diode. A Zener diode is a PN junction semiconductor device, just like a normal diode, but this is designed to operate in the reverse breakdown region. So for us to understand reverse breakdown region, we'll go back to the VI characteristics of the diode. We will see the breakdown region. However, this breakdown region is into two that I will discuss as we proceed. Now, this is the how a Zener diode looks like in real life. However, this is the circuit symbol. You see that this is the normal diode. We now have this symbol in front of the cathode. So it has the anode and the cathode. However, this is operated in the it's always is reverse bias because when for a normal diode, rectifier diode, we put the positive terminal of the voltage source at the anode and negative at the cathode. We say we forward bias, but in this case we reverse bias, negative at the cathode, positive at the anode. Now let's look at the two breakdowns that we have. They are avalanche breakdown and Zener breakdown. Avalanche breakdown occurs in both normal diode and Zener diode at high reverse voltage. So when we reverse bias and the voltage is high, we can have avalanche breakdown in any diode. What happens here is that when high reverse voltage is applied to the PN junction diode, the free electrons of the minority carrier gains large amount of energy and accelerates to greater velocity. By the time it gains energy, it accelerates, so it's moving very fast. And the free electron moving at this high speed will collide, not collide as a, so you can remove this S with the atoms and knock off more electrons. These electrons are again accelerated and collide with other atoms. So this continues in a chain reaction. As a result, electric current in the diode increase rapidly. This sudden increase in electric current will permanently destroy normal diode. So if the process continues in a chain reaction like that high velocity electron collide with atoms and knock off more electrons, continue like that. For a normal diode, the diode destroys. But for avalanche diode, it may not be destroyed because they are carefully designed to operate in avalanche breakdown region. Avalanche breakdown occurs in Zener diode with Zener voltage Vz greater than 6 volts. Usually in that when it's greater than 6 volts. Now for Zener diode, the breakdown occurs in heavily doped PN junction diode because of their narrow depletion layer. The depletion layer is very narrow. So when reverse bias voltage applied to the diode is increased and narrow the depletion region the narrow depletion region generates very strong electric field. When reverse biased, the voltage applied to the diode reaches close to Zener voltage. The electric field in the depletion region is strong enough to pull electrons from other avalanche back or other valence back. The electrons which gain sufficient energy from the strong electric field of the depletion region will break bonding with the parent atom. The valence electron which break bonding with the parent atom will become free electrons. So these free electrons carry electric current from one place to another. At Zener breakdown region, a small increase in voltage will rapidly increase electric current. Now let's look at the difference between Zener and avalanche breakdown. Zener breakdown occurs at low reverse voltage, whereas avalanche breakdown occurs at high reverse voltage, often greater than 6 volts. Zener breakdown occur in Zener diode because they have very thin depletion region. The depletion region of Zener diode is very thin. That's why Zener breakdown occurs in it. Breakdown region is the normal operating region for Zener diode. So when you have that Zener breakdown, so that's the non-operating region for a breakdown grid. And as we have said earlier, Zener breakdown upon a Zener diode with Zener voltage less than 0. For a Zener diode, Zener voltage occurs with voltage less than 6 volts. Now let's look at this for a Zener diode. This is reverse bias region. Uh, when this is a negative voltage and the currents here, with increase in voltage, the reverse saturation current will be very small. But the breakdown region, the voltage the currents increase sharply. Zener breakdown. And you notice here that the voltage remain constant. So a little change in voltage causes very high. Here voltage increase does not cause current increase. When getting to the breakdown region here, because it's reverse bias, so I'm getting to the breakdown voltage here, the current increase sharply. So and this voltage breakdown, the voltage here remains constant, which is the VZ, the Zener voltage. Now let's look at that's the VI characteristics of a Zener diode. So when the valve voltage is applied to Zener diode, allows only a small amount of leakage current until the voltage is less than the Zener voltage. When reverse bias voltage applied to the Zener diode reaches Zener voltage, it starts allowing large amount of electric current. At this point, a small increase in reverse voltage will rapidly increase the electric current because of the sudden rise in electric current. Breakdown occurs called Zener breakdown. However, Zener diode exhibits a controlled breakdown that does not damage the device. The device is not damaged, but it's a control since it's a control group. Zener breakdown voltage of Zener diode depends on the amount of doping applied. If the diode is heavily doped, Zener breakdown occurs at low reverse voltage. On the other hand, if it's lightly doped, Zener breakdown occurs at high reverse voltage. So if heavily doped, you just need low reverse voltage to start it. So Zener diodes are available with Zener voltage in the range 1.8 volts to 400 volts. So when you buy a Zener diode, the VZ, the Zener voltage, is always stated on the data sheet. So once you get the number for the Zener diode, then you can get electronic data sheets to know the Zener voltage, so as to know how to apply it in your electronic component. So application of the Zener diodes are as listed here. It is normally used as voltage reference. Now, we will explain that anyway. Zener diode are also used in voltage stabilizer or as shunt regulator. You may want to get a voltage regulator that you ensure, like in your charger for instance, after rectifying the AC source, you may filter it using capacitor, but the signal still vary with input current, not as smooth as we would like. But applying a Zener diode will make it give it a constant value as long as the input reverse voltage is sufficient to reach the Zener breakdown. So Zener diodes are used in crimping and clamping circuits. We explain this as well too. And Zener diodes are used in protection circuits. Thank you. God bless you.